Yeah, Mihai is working on actually the Internet of Agreements with Mattereum. Maybe you people also know Vinay Gupta, which is his partner in this venture, basically. And Mihai is the chief engineer. So when we want to get into the technical side of stuff and what you can build with Ethereum and yeah, solve something really valuable, then Mihai is the guy to kick off with. I would like to invite you to kick off the tech deep dive with your keynote, Mihai. Thank you. Applause, please.
All right. Hi, everybody. I guess the introductions were made already. My name is Mihai. I'm chief engineer at Mattereum. And I'm here to talk about the Internet of Agreements. Or, to put it in another way, what are these blockchains for anyway? So, let's discover together. So, although he said nobody will explain what a blockchain is, I'm still going to do that. So a blockchain is a global distributed database which has a bunch of very nice features like immutable history, digital signatures already built in, a supposedly fair solution to consensus, and some level of programmability, which some people call smart contracts. And a bit of history of, and to see and position ourselves where we are right now. So in the 90s, there was what we call the Internet of Ideas, which was based on some simple protocols, HTTP, SMTP, FTP, which basically brought us some simple tools for information sharing, like documents, emails, wikis, blogs, you name it. And then, after we thought about this problem a bit more, and we kind of put some layers of security on top of the basic protocols, we got to the Internet of Shopping, which basically, with the enablement of payments, brought us Amazon, Netflix, and all the nice services that we're using nowadays. So we like to think that we're moving towards the idea of Internet of Agreements, which is built upon tools like blockchains, smart contracts, automated logistics, hopefully AI soon, which can do multi-party, conditional, long-term agreements, modeling complex business workflows in a trustless way beyond company trust barriers. So, although you probably know this, there's some programmability trade-offs in writing blockchain applications for things like Bitcoin. We agree already from the get-go, how many Bitcoins there are, who owns them, how they get to own them, and the rules for moving them around. This is kind of simple, safe, effective, because the rules are restricted. Whereas with Ethereum, we get to define the rules ourselves about how we manage assets and business workflows. And of course, with great power comes great responsibility. And smart contracts are actually hard to develop. We all know that normal software has a lot of bugs because the mantra is, move fast, break things, deliver as soon as possible, and deliver often. But with smart contracts, they are different, because even a small piece of code, like a wallet software, can hold millions of dollars of value, and a lot of thought and diligence needs to be put even in a very small piece of code. But as we all know, smart contract fails sometimes. And although there's a perfect audit trail of what happened, it's not always very easy to fix. So we at Mattereum, we want to go the next level and bring kind of physical property to the blockchains. And although you can't put your house on the blockchain, you can certainly put a contract that will manage the ownership and rights into that particular asset. And this needs a needs two things. It needs a high standard of engineering. So we make sure that what we put there on the blockchain is actually of high quality. And although we did as much as we could to make that safe and work well, things will go wrong. And Mattereum's proposal to fix things when they go wrong is to set up a dispute resolution process. So this brings us to the question, what is Mattereum? What is the company that we made? So it's a standard and quality assurance platform that will provide knowledge, expertise, and tools to build legally enforceable smart contracts. We call these Ricardian contracts. That's because Ian Grigg, our chief scientist, he invented this concept about 20 years ago. So what's a Ricardian contract? It's basically a pair of a classical prose contract together with a smart contract, referencing each other, and the prose contract, the PDF, delegating some of its functionality to the smart contract. We want to set up what we call a decentralized dispute resolution arbitration, which by using the 1958 New York Convention will be legally binding and recognizable in more than 150 countries. We are based in London, and that is important because London is, among other things, a center for arbitration. We are essentially basing our assumptions on the same basis that the maritime arbitration community did. So basically, all disputes related to maritime conflicts are resolved in London by the Maritime Arbitration Association. So they are not raised in the countries of origin of different ships out there. They are raised in London. And this is what we want to do for smart contracts. And we also have legally enforceable blockchain smart contracts running right now. Let's see if we can actually run them. This was the theoretical part until now, and because we are at a technical conference, hopefully this will work. Don't be black, don't be black. It's not black. Okay, great. People have kittens, we have dogs. So when I joined Mattereum, I wanted to build something that people will see. And this is essentially a proof of concept application that I built. And I'm going to present a highlight of the entire stack. So it's an app that right now can be downloaded from the Google Play Store. It's called EtherCam. Hopefully you will see something. I've been told that the new MacBook doesn't get along with the hardware here. All right, so it's a mobile app which has a wallet inside. What we call ETR, it's actually Ether from the Rinkeby testnet, the Ethereum testnet. So the app has a wallet, has a private key. And what it does is essentially model the process of publishing photos and publishing an offer for licensing of these photos to the world. So that is done using a smart contract. And then a buyer, and this is what I'm going to show you here, will go through a two-steps process of acquiring a license for such photo, which will then be able to take and share and use commercially in any way he pleases. So essentially, this is how the process works. You can view a license draft. So you know what you're signing, actually, when you're pushing the button to go through the smart contract, and that's not helpful. Right? And then after you carefully read all the pros, you push the button to send the payment. So essentially what happens now is that the app builds and signs an Ethereum row transaction and delivers it to the blockchain. We're waiting for confirmation. Hopefully this will work, but if not, I've also prepared some screenshots. The Rinkeby testnet last night was not behaving very well. It took 5 minutes for the transaction to actually go through. But when it finishes, it will look like that. Oh, man. This is not helpful. Right, so the next step of the process would be to sign the actual contract. So why I built this smart contract like this is because according to our lawyer, Chris Ray, which is a partner in Mattereum, in English common law, you actually need two parties for a contract to be named in the contract. So the app manages the identity of the people off the blockchain. And in order for us to release the identity of the publisher of the photo to the buyer, we need some kind of reassurance that he's actually willing to buy that photo and is not just scraping identities of people. So for that, we basically took the first step to take the money up front. The money is now in the smart contract. And then the next step is the app will release the identity. And, well, actually, this is the transaction being confirmed now. Takes a bit more than usual. So now the identity has been released, and we can actually see the pros contract, which looks like that. Yeah, you're seeing everything good. So, yeah. So there are two parties to the contract, the licensor and the licensee. The work here is the hash of the photo, and the fee is guaranteed there. And the licensor basically says that he owns the IP of this photo and he's willing to license it to other people. And the interesting part here is that some work of this pros contract is delegated to the smart contract, and the pros has a reference of the smart contract that is already deployed, and it also has a reference to the source code of the smart contract, which can be read by an arbiter or some kind of other authority which will be looking to resolve disputes arising from this particular contract. So that is the interesting part. Now we push the button to sign the actual agreement, and another transaction will go into the blockchain. If you want to take a look at this, you can see the source of the smart contract. This is a transaction that I just sent. So it's deployed publicly, and the source of the contract can be found here. You can take a look if you want. Now, actually, the license has been granted. And you can view the contract that you signed, and you can use the photo as you please. If you guys can switch back to the presentation, I finished with the demo, and now let's try to dive a bit deeper into the architecture of the app and how to show you how easy it is to build kind of consumer-ready, I would dare to say, applications using this particular stack that I chose. Switching back, right. So this is the architecture of the app. So as you can see, the app itself had a private key inside of it, so it's communicating with the blockchain directly. So our backends are not intervening in any way there. The backend, which here is highlighted as the EtherCam API, only maintains a cache of the state of the blockchain. So, and because blockchains are inherently slow, as you saw, we'd like to serve the data faster. So we serve it initially from the backend, and then the app will recheck with the blockchain to see if the data is up to date and if it's still valid. So the blockchain will at all times take precedence over the backend data, but we'll serve it faster because we want this to be usable. We also initially tried to store everything in IPFS, and we discovered that is not really doable right now. But we are storing pictures in IPFS and uploading them asynchronously there. And as you saw, the app had, on the app, some pictures had the IPFS logo on them. That means for those pictures, we already uploaded, and images are available from IPFS as well. But the app is serving from S3 because it's faster. Right? So let's take them piece by piece now. So the mobile client is implemented using Ionic framework, and I recommend you to use it. It works. It's very good. It's a cross-platform framework, and the language that you write code in is called TypeScript, which is the superset of JavaScript with classes and types, and it's very nice. And you get the benefit of writing essentially JavaScript, which is compatible with the Web3.js, Ethereum library, and the other very nice crypto libraries out there, which are all written in JavaScript. And you will have a hard time finding native application libraries for all of this stuff. And it just makes the life of the developer really pleasant. So Ionic uses the same concepts that AngularJS uses. So it's basically based on AngularJS, and it interacts with native components of the operating system via Apache Cordova plugins. As I said, the blockchain transactions are sent directly from the app, signed from the app directly to the blockchain node. The backend API is written using Nest.js, which you'll probably guess it's still based on Angular, and it uses the same architecture. So essentially, the developer is writing most of the time the same code on the mobile app and on the backend. It sits on top of Express, and it's deployed as a Docker container or containers using the hyper.sh cloud, which is another very cool tool. As I already said, the backend is there to store the private off-chain parts that we don't want to put publicly, like the names of the people involved. And it also stores a cache of the licenses to be served faster. Already said things about S3 and IPFS. The app, when you want to publish something, you upload directly to the backend, which synchronously uploads to S3, and then there's a cron job which uploads to IPFS because it takes a long time. And the photos are marked as uploaded only afterwards. The smart contract itself, of course, is implemented in Solidity on top of Ethereum, tested with Truffle, lots of unit tests, and I recommend you to use it because it makes it very easy to write tests for smart contracts. The code of the smart contract is available on Etherscan alongside the contract. The contract itself is basically modeling the business workflows that are needed, and in this demo example, to license a photo from somebody. And the smart contract is just one of them, so it's not a smart contract per photo, it's just one smart contract container that has all the licenses. It saves costs and we don't like duplicating code on the blockchain. But what makes this legally enforceable? And I'm going to read this because it's written by our lawyer. There needs to be evidence of a contract with clear written terms. An arbiter can only make a decision based on those clear written terms, and the arbitration award can be enforced in any national court among the 150 countries that are signatories of the 1958 New York Convention. So basically, we have a prose PDF, which references the smart contract, and then the smart contract has, with each license, a hash of the PDF that is the actual license for that photo. So it's a pair. They work together. They're also called. It's also called Ricardian pair. Also, the PDF has a clause which, in case of a dispute, sends the parties to arbitration instead of litigation in national courts. We like to refer to this as business insurance not to go bankrupt. And we had our first arbitration. We call it mock because the arbiter didn't actually write the award on a piece of paper, but the arbiter was a Queen's Counsel judge from the UK, so he was an actual judge. The story works like this. The Ethercam contract states that the publisher needs to own the IP of a photo before publishing. So the original guy who published the photo of the pineapple, we call that the originator. And then the second publisher took a photo of the photo with the pineapple and published that for licensing as well. The buyer, in his innocence, bought the pirated photo, and then when he realized that, he raised the dispute against the seller, and the dispute went to arbitration. The arbiter basically awarded in favor of the buyer because that was a clearly pirated photo. He awarded his money back for the license and also £5 for damages, which unfortunately the guy had to pay his lawyer. Thank you.
Great. So just one question, Mihai. Yeah. So now you have worked this out for settling on transactions with pictures. So what would you see in the next coming years? What you can build on the same platform? What would you see coming next?
So next, we are working with our clients and partners, and so basically we are building bespoke solutions for a while until we start seeing patterns. And from those patterns, we will build templates which people will be able to use. Our first client, which will be announced hopefully today or tomorrow, will be the Ocean Protocol, wow, which is a big data market which will be coming online soon. I hope everybody knows about it.
Yeah. So if you want to know more, join Mihai in the decentralized Q&A later today. As we have a very tight schedule, I suggest we move on to the next speaker. But first, and especially a big hand of applause because a live demo on stage is always really, really cool. Thank you so much, Mihai.
Thanks.